Hi everyone. As you can see, I've spent a little time on the setup end of things and have put together a way that I can work the problems that you were assigned and just give you a little more guided practice on this end so you're not left hanging and seeing and wondering if you had the correct answers. So what I've done here, I have a document camera right in front of me. I have some paper on it. If I switch the screen, there it is. So there's number one. Right now though, you can see the assignment. This is just to give me something to talk about here, and I have this fancy webcam pointing at me. So this week you were asked to spend a little more time practicing simplifying radicals, which is something we did as we left before spring break and before we started learning remotely. Then what we added on are two sort of problems where you multiply and divide these same sort of rational expressions. So what I'm going to do is work through the first two problems, then upload a second video, or maybe even a third video depending on how long 3 and 4 take here. So what we're looking at right now are numbers 1 and 2, number 1 and number 2. So let's flip to the document camera. Oh my, there we go. All right. And working through number 1. So number 1 asks us to simplify and then identify any x values for which the expression is undefined. So here we go. So if we look at this problem, we notice there are quadratics on top and bottom. Resist the urge to cancel the x squareds and cancel the 36s. Those are common terms. They're not common factors. We can only reduce common factors rather than common terms. So what we need to do is rewrite this in a way that we can look at different factors that this has. My pen is dying right now. We'll see how it goes. So we can rewrite the numerator because it's a difference of two squares. We can rewrite it as x plus 6 times x minus 6. As we've done a lot of factoring, I'm not going to walk through that specific part. If we multiply it back out, we'll see that it ends up being x squared minus 36. So like we were saying in class, what we want to look for now is one of these two factors in the denominator, because if we can reduce a factor, it has to be common on both. So we know what to look for here. So I notice this and say, well, 36 and 12, since a is 1 here, this one's not too bad to factor either. I know it's going to factor into x and 6, and I just need to decide what the signs are. So because there's a plus in the back, this is the result of multiplying two numbers of the same sign, and they must both be negative because that's what they combine to. So this is x minus 6, x minus 6. So now we can look at this and say, well, there's a common factor of x minus 6 in both the numerator and denominator, so it factors out. So in the end, we can say x squared minus 36 all over x squared minus 12x plus 36 is the exact same thing. It's equal or equivalent to x plus 6 divided by x minus 6. This form's a lot easier to work with. I can substitute numbers in for x, say like 4. I can put 4 in. This is 10 over negative 2. It's a lot quicker than putting 4 into this and realizing, well, I have to work through it and get to the same problem. Now the second thing we were asked is to identify any x values for which the expression is undefined. I'm looking right there. Now expressions are undefined when the denominator becomes 0. So what we're worried about is what makes the denominator 0. So what makes this x squared minus 12x plus 36 become 0? Well, we know it's equivalent to x minus 6 times x minus 6. So we can really ask ourselves, what makes x minus 6 become 0? That's the question we want to ask for undefined values. Well, we can solve this. Pretty straightforward. Add 6 to both sides. X is equal to 6. So it's undefined. This polynomial does not exist, or this rational expression does not exist when x equals 6. So two parts right here. All right, let's head to number 2. All right, on to number 2. Bowen's in the room. I don't know if you can hear him grunting. We'll see what happens here. He's okay. All right, so going through this, I want to see if I can factor anything out of this first because there's a lot happening here. 2 and 9 don't have a common multiple, so I can't factor anything there. They're both negative, though, so I can get rid of the negative in the numerator. And they both have a factor of x. So what's left when we factor a negative x out is 2x plus 9. The signs flip because we factor the negative out. Denominator, can I factor anything here? 4 and 81 don't have any common factors, so unfortunately we can't do that. But we notice that this looks a lot like the numerator in the problem we just did. So we can factor this actually into 2x. 2x to get 4, 9, and 9. Hey, look at that, 2x and 9. We were looking for that already, so we kind of knew what direction to go. But because this is a difference of two squares, just like the last problem, the signs are opposite here. So we have plus in one, minus in the other. So if we notice, 2x plus 9 cancels out now. So we can say negative 2x squared minus 9x all over 4x squared minus 81 is the exact same thing as writing negative x all over 2x minus 9. So what we're worried about again here is what makes the denominator 0. There's a lot of ways of doing this actually. We can go through and look at the factors. I noticed they're the same thing, so it's just going to be plus or minus. We can solve it by square rooting also. So I'm going to go through and solve this with square roots instead of looking at the factored form, just so we can brush up on that strategy of doing it. So here we can say, well, what makes 4x squared minus 81 equals 0? And we can solve this by solving for x, basically. So add 81 to both sides. We get 4x squared is 81. Now divide by 4. We get x squared is 81 fourths. And finally, we can square root this to solve for x. So square root the left, square root the right. We get x is plus or minus here. Square root of 81 is 9. Square root of 4 is 2. So plus and minus 9 halves. We can also solve that by looking at this denominator and saying, well, subtract 9 divided by 2. Add 9 divided by 2. That will get us plus or minus 9 halves also. So two ways of doing that. So that's it for these two problems. Go ahead, look for the next video, which covers number 3. And then I'll probably create another video for number 4 just so we can break it up.